Hello everyone. It's a pleasure to join you at the BCS Virtual Festival of Digital Skills. My name is Matt Forshaw, and today I'll be speaking to you about skills in computing and specifically in data science. This talk will draw on my experience working as Programme Director of Data Science Programmes at Newcastle University, and also in my role as National Skills Lead at the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. My contact details are available on this slide, and I'll be very happy to discuss these topics further if you're interested. I've also made available a copy of my slides, as well as an accessible transcript and additional resources at the GitHub link shown on the slide. To set the scene, I'd like to speak about three key challenges in the data skills space at present. In particular, I'll focus on those which represent the most significant barriers to progress. The first issue concerns terminology and nomenclature. Within academia, there are genuine arguments around what constitutes data science and AI, and these haven't been satisfactorily resolved by prior efforts at standardisation. We observe a significant increase in the number of university programmes and other training offerings in data science and AI, but with their differing emphasis, their contribution to addressing a severe skills need is difficult to assess at a glance. Challenges around terminology perpetuate through the labour market, leading to inconsistent use of role descriptors, which complicates skills assessments, recruitment and hiring practices. The second challenge is around a lack of alignment between training offerings and the needs of the workforce. It's particularly encouraging to see revitalised discussions around the professionalisation of the data science occupation, including many professional bodies in this space, including BCS, the Royal Statistical Society, the OR Society and the Royal Academy of Engineering. This will explore the role of accreditation to ensure education programmes deliver the right skills and knowledge for those looking to enter the profession. Finally, we must focus on raising awareness and widening access to the variety of routes to academic and vocational training, with a particular emphasis on attracting historically underrepresented groups to the field. When I talk about skills in data science and AI, I love to start with this Venn diagram. I think this really speaks to the interdisciplinary nature of the field, bringing together skills from computing and maths and statistics, as well as subject matter expertise. The centre section of the diagram here is referred to as unicorn, based on this rare, almost mythical blend of skills which we can hardly expect one individual to fully fulfil. Each year when I welcome students to my data science programmes, we run an exercise where I encourage everyone to position themselves within this figure based on their previous experience, prior qualifications, confidence levels as well. What this shows is the diversity of background of our students, which is always really exciting, but also the tendency towards imposter syndrome in the field. We have students from computing backgrounds whose last memory of maths and stats was large class sizes back in school. We have students from maths and stats backgrounds who feel slightly daunted by some of the contemporary tooling and software engineering best practices in relation to data science and AI. And we also have individuals returning to study from careers in industry who are quite intimidated by the higher education environment, and new graduates who are equally intimidated by the commercial experience of these individuals. Meanwhile, I'm somewhere in the middle, feeling a healthy dose of imposter syndrome coming from each of these directions. I've since come to see this diagram as a fantastic way to position training offerings in data science and AI. The ideal is to have equal representation across computing and maths and statistics in the delivery of training. The reason for this is not that statistics training can't be delivered adequately by those from other areas. Rather, that what we'd like to be able to highlight to our learners is the research advances which will impact their professional practice in 5 or 10 years' time. You could just about convince me to teach an introductory statistics course, but I wouldn't be able to speak to the research advances in a compelling way as someone who is working at the frontier in that field. Where I'd like to focus most of my time on this talk is in this third intersecting segment here, not the computing and the skills aspects. It's shown here as subject matter expertise, and other versions of this diagram refer to this as commercial acumen. Looking at these other areas is particularly important when we consider findings such as Gartner's here, showing that 85% of big data and data science projects fail to move from proof of concept to production. And this has been shown primarily to be for organisational rather than technical reasons. These are factors which severely inhibit the translation of data science and AI developments into practice. At Newcastle University, we look to address these challenges through training on data-driven innovation. We deliver this training as a 10-day incubator programme in collaboration with the National Innovation Centre for Data. We equip students with commercial awareness around the use of data and AI as well as its limitations. And through this process, students are immersed in an industry setting working alongside stakeholders on real business problems. Collaborative curriculum co-development like this, working with diverse partners, naturally requires significant resource and experience and expertise. At Newcastle, we're fully committed to ensuring that our training reaches the greatest number of learners possible. And to this end, all of our curriculum materials are available open source under a very permissive Creative Commons license for adoption with your own learner groups and in other programs. So please feel free to get in touch if you're interested in finding out more. Anaconda, in their The State of Data Science 2020 report, surveyed over 2,000 people between February and April 2020. They found that only 15% of university graduates in data science believed that they had received adequate training on ethics. It's clear that we must embed ethics throughout the taught curriculum rather than just in elective modules. A question I'd like for us to debate in the Q&A section of the virtual festival is this: how might we support our learners in their professional practice upon graduation? Of course, we can impart values and ways of thinking to our learners, but how do we equip them to uphold these values in professional settings where colleagues or the organisation as a whole don't necessarily share these values? It's critical that we consider these cultural issues as a cross-cutting concern in our data science curriculum. In particular, we need to develop strong awareness of algorithmic bias and fairness, which risks creating exclusionary experiences and discriminatory practices. These biases may arise, for example, from a lack of diversity in training sets for machine learning models. Open source libraries and pre-trained models then perpetuate these biases with very low friction for them being incorporated into tools and projects which have a very real impact on society. We need to explicitly check the impact of bias during development and testing, and advocate very strongly for diverse teams with different life experiences to govern the development and use of these technologies. This diversity is essential to the development of a robust data science skills base. Therefore, we need to draw on the country's entire intellectual capital. Progression into postgraduate training in data science is as low as 11% for Black and 8.4% for disabled students. The inequitable impact of COVID-19 on women and BAME communities is likely to have slowed progress on diversity and inclusion across all sectors. When we consider the Office for National Statistics estimate that over 70% of 1.5 million roles at risk of automation, such as AI, are held by women, it's clear that urgent intervention is required. For those interested in this topic, I highly recommend BCS's report, Scaling Up the Ethical AI MSc Pipeline, by Bill Mitchell, who's also speaking today. One of the most promising steps in widening participation was that in June 2020, the Department for Digital Culture, Media and Sport, alongside the Office for AI, announced £13 million to support degree conversion courses in data science and AI. This includes £10 million for up to 1,000 scholarships for people from diverse backgrounds, and this was matched by an additional £11 million from university and industry partners. At Newcastle University, we're one of the 13 universities to receive this funding, and we recognise the significant contribution that these £10,000 scholarships make to our learners. We also look to support our learners through some additional mechanisms. We offer pre-sessional training to help applicants to develop confidence in the HE setting, to identify themselves as beneficiaries of these courses, and to attract applicants from outside of STEM disciplines. We allocate industry mentors who hold leadership roles in data science, many of whom themselves are from historically underrepresented groups in the field. Finally, we guarantee industry internships at the point of entry for our scholarship holders. Through this national scheme, we will see a total of 2,500 learners equipped with data science and AI technical skills, as well as the contextual knowledge and experience to apply these to real-world problems. One area I've been particularly involved in over the last 2 years has been in establishing the Artificial Intelligence Data Specialist Apprenticeship, which runs at a master's level. This standard was developed by a trailblazer group led by the BBC, and including many of the organisations, universities and training providers shown in the top right of the slide. This apprenticeship began delivery in October, with a further cohort joining in January 2021. For those interested in the fantastic opportunities offered by apprenticeship training, I've highlighted 2 excellent sessions led by the Institute for Apprenticeships and Technical Education, and a session on apprenticeships' role in economic recovery and growth, both taking place part of this festival. We must continue to work to meet the needs of industry and skills offerings. There are now calls for further discipline-specific flavours of apprenticeship standards. For example, the Science Industry Partnership Skills of 2030 reports advocate strongly for apprenticeship standards for the life sciences. We need to work to ensure that there's consistency across these standards, that they continue to provide valuable routes to upskilling in areas of critical importance, and crucially that funding routes are available to SMEs. In terms of next steps, we must develop training which promotes a culture and environment that retains data science talent, including supporting interdisciplinary data science teams. We must work to democratise and widen access to training which is both responsive to industry need and available for delivery at scale. This can include on-demand retraining through MOOCs, short courses and open curricula. We should also work to encourage strong alignment between training providers and industry need to ensure high standards and appropriate training to equip a diverse workforce with the skills necessary to succeed. Thank you very much for listening, and I'll be very happy to take questions through the Q&A area or by email. I'll continue to contribute resources at the GitHub link shown on the slide. Thank you very much, and I do hope you enjoy the rest of the festival.